In this video, we're going to walk you through how to conduct a microplastic recovery experiment. You'll start by cutting brightly colored polyester thread under a microscope to get precise, uniform pieces. We recommend using an X-Acto knife for better control and cleaner cuts. It might take a little time, but it makes a big difference in the quality of your fibers. After cutting, make sure to measure each fiber. We're aiming for a size range between 300 and 500 microns. Be sure to document the measurements to keep your samples consistent. To double-check accuracy, you can use digital imaging software to remeasure the fibers. This helps catch any outliers and ensures your dataset stays reliable. For each soda tablet, you'll need 25 microplastic fibers and 25 microplastic spheres. Since the spheres already come prepackaged in the correct size range, 70 to 90 microns, you'll just need to separate them. Once everything's counted, you're ready for the next steps in this experiment of making the soda tablet. To prepare the soda tablet, begin by measuring 12.5 milliliters of baking soda and 4 milliliters of citric acid using a small beaker. This makes 2 to 4 tablets. Proceed by mixing the powders thoroughly, then lightly spray the mixture once or twice with water using a spray bottle. This step adds just enough moisture to help the mixture bind without activating the fizz reaction. Using a lab scoop, transfer the hydrated mixture into a silicone mold. Then use the spoon end of a spatula to firmly pack the mixture into each mold cavity, but don't fill it completely. You need to leave room for sealing later. Then take the bottom end of a small glass tube and gently press a central hole into each tablet. Make sure it's deep enough to hold microplastics, but not so deep that it weakens the structure. To prepare the microplastics for the soda tablets, place the fibers and spheres onto a glass slide and check them under UV light for even distribution and visibility. Then dust the microplastics with lactose powder, which acts as a binder. Then apply a few drops of methanol using a pipette to help the particles congeal slightly and hold together. Carefully transfer the encapsulated microplastics into the cavity of each tablet. Next, take a small amount of the original powder mixture and use the spatula to cover and firmly press it over the top, sealing in the microplastics. Once sealed, check all tools, surfaces, and work areas under UV light to ensure that no microplastics were lost during preparation. Let the soda tablets air dry completely in the silicone mold. Cover them to prevent contamination and store in a dry environment. Once dry, the tablet can be dissolved in water, releasing a known quantity of microplastics for controlled testing. To begin, we label our materials starting with our mason jar. Start by rinsing out the collection bucket using creek water. This step helps clean and condition the bucket before we collect the actual sample. Once rinsed, we collect a full bucket of creek water to use as our test sample. Now we take the soda tablet we just made and drop it into the bucket. As soon as it hits the water, the tablet begins to dissolve, releasing the microplastics into the sample. To make sure nothing escapes during the reaction, we cover the top of the bucket with aluminum foil. After the reaction is complete and the tablet has fully dissolved, we pour the contents of the bucket through a sieve to capture the microplastics. We set aside the fallout water for later and now focus on the plastics collected on the sieve. Using a squeeze bottle, we begin carefully rinsing the sieve to transfer all the collected microplastics into a clean mason jar. Make sure to rinse thoroughly and spray all surfaces of the sieve to make sure no particles are left behind. This step is essential for maximizing recovery and ensuring consistency in our results. Before using the system, we thoroughly rinse the entire apparatus with deionized water. This step helps remove any dust or contaminants that could interfere with our sample. Next, we place a piece of gridded filter paper into the funnel. Then we pour our spiked water sample from the mason jar into the top of the funnel. Using the vacuum pump, we pull the water sample through the system. The water passes through, collecting in the flask, while the microplastics are trapped on the surface of the filter paper. To make sure we capture everything, we go back and rinse the inside of the mason jar, swirling and pouring the water into the funnel. We also rinse the walls of the funnel, ensuring that no microplastics are left clinging to the glass. Once all the water has passed through, we release the vacuum pressure and carefully remove the filter paper using forceps. The filter is then placed into an aluminum petri dish and we cover it with aluminum foil to prevent contamination during drying. To begin, start by filling out your microplastic analysis data sheet. Next, take the recovered sample from filtration and place it under the microscope. Using the UV light, illuminate the sample. Protective UV filters are attached to the microscope to shield your eyes during analysis. Under UV light, microplastic fibers and spheres fluoresce green, making them easier to detect and count. Begin counting each visible fiber and sphere. Take your time to scan the filter area to avoid missing smaller particles. In this recovery experiment, look for consistent fluorescent patterns. Fibers appear elongated while spheres are round and bright. Record your results directly onto the datasheet, noting the number of fibers and spheres recovered from each tablet. To verify recovery, we use a fluorescent light to scan every surface that came into contact with our sample. We check the mason jar, sieve, and collection bucket, looking for any microplastics that may have been left behind. We also inspect the utensils in the fallout water, making sure we account for every possible point of loss. If we find stray particles, it helps us identify gaps in the procedure and improve future recovery. From preparing microplastics and making soda tablets, to dissolving, filtering, and analyzing your samples, you've now seen each step of the microplastic recovery process. With these techniques, you're fully equipped to carry out your own recovery experiment and collect meaningful data.